Imagine running a cybersecurity test on an AI model. It's supposed to be completely isolated. No internet, no access to real companies, no production systems. Then someone makes a configuration mistake. The AI can reach the internet. It finds a vulnerability, exploits it, and systems belonging to a real company get modified. This isn't hypothetical. This is what Meta says happened during a cybersecurity evaluation of its AI model, Muse Spark 1.1, and it isn't isolated. OpenAI has reported a similar incident. So has Anthropic. All three cases trace back to the same external security firm, Irregular. So what actually happened? Did Meta's AI escape a sandbox? Did it deliberately attack a company? Or was the real failure somewhere else entirely? Let's break it down. Meta's Muse family is built for more than answering questions. These are agentic models designed to reason, write code, use tools, and take actions on their own. That's exactly why cybersecurity is such a useful test. Instead of asking a model to explain a vulnerability, researchers can give it a sealed environment and ask it to find one. That's what an external testing firm called Irregular was doing with Muse Spark 1.1, measuring what the model could actually do inside a controlled, isolated environment. No real internet, no real targets. Then a configuration mistake happened on Irregular's side. The environment was accidentally connected to the live internet. Meta and Irregular are both clear about this. It was not a sandbox escape. The model didn't break out of anything. The door was left open by a misconfiguration. Once it had that access, the model found a real third-party service. It found a vulnerability. It exploited it. Internal files at that company were modified before engineers caught it and shut it down. We don't know the exact vulnerability. We don't know which company. Meta hasn't published its full retrospective yet. But the sequence is confirmed. Misconfiguration, internet access, a real exploit, real changes to a real system. Headlines call this an AI escaping its sandbox. That's not quite right. A real sandbox escape means the model was properly contained and found its own way around the controls. That's not what happened here. The model was accidentally handed access it was never supposed to have. That's a configuration failure, not a breakout. But don't let that framing make it sound minor. Configuration mistakes happen constantly in real infrastructure. Firewalls, access controls, credentials, network routes. Humans get them wrong all the time. What's different now is what's on the other side of the mistake. A human attacker exploiting an accidental opening still has to notice it, understand it, and act, usually slowly. An AI agent doesn't carry that lag. And there's another detail worth being precise about. Nothing suggests Muse Spark found some brand new zero-day. It didn't need to. The real question isn't whether the model discovered something novel. It's whether it could recognize an opening and turn it into real-world action. Here, the answer was yes. Here's the mechanism in one sentence. The model observes, reasons, acts, then observes what changed and does it again. Give it an objective, and that loop can run continuously: scan, analyze, try something. Watch the result, adjust, try again. Inside a properly sealed test range, that loop is exactly what makes these evaluations useful. But the moment the network boundary fails, the same loop stops being a benchmark. It's now running against real infrastructure, on its own, with nobody in the loop to slow it down. And this is where the story gets bigger than Meta. In late July, Irregular was running capture-the-flag-style cybersecurity evaluations for OpenAI's models, environments explicitly designed with no internet access. A misconfiguration gave the models internet access anyway. And in one test, the fictional target used in the simulated challenge happened to share its name with a real website. The model exploited the real site, treating it as part of the exercise. It even found working credentials there. Different failure, similar cause, an evaluation environment that quietly stopped being isolated. Then came Anthropic. After OpenAI disclosed its incident, Anthropic reviewed more than 141,000 of its own evaluation runs. It found 3 separate incidents, 6 runs in total, where Claude models reached real production systems at 3 different companies, because the environment falsely told them they had no internet access when they actually did. The evaluator on that review, Irregular again, 3 frontier labs, 3 separate incidents, 1 shared evaluation partner and the same underlying failure each time, a test environment that wasn't actually sealed. So how do you actually contain a model being tested for offensive cybersecurity skill? Not just put it behind a firewall. A serious lab needs layers. Real network isolation, with no default path to the public internet. Egress controls that only allow explicitly approved destinations, not just block by default and hope. Credentials that are fake and disposable, never reused from production. Infrastructure that's ephemeral. If the model compromises a test machine, destroy it and rebuild, don't patch and continue. Everything logged, every command, every connection, every file change. And an automatic kill switch the moment the model reaches somewhere it shouldn't. Above all, design the lab assuming the model will eventually find the boundary, not that it will politely stay inside it. For years, AI safety conversations centered on the model itself. Is it aligned? Will it refuse dangerous requests? Can it be jailbroken? Those questions still matter. But agentic AI adds a second dimension that gets far less attention: the safety of the environment around the model. A perfectly aligned model given a leaked credential is still a security incident. A model explicitly told to run a penetration test will legitimately try to exploit what it finds. That's the assignment. And a sandbox with one open route to the internet isn't a sandbox at all. So did Meta's AI escape? Not based on what we actually know. The sandbox wasn't broken into, it just wasn't closed. And once Muse Spark had a path out, it showed exactly what these models can now do with one: recognize an opening and turn it into action without anyone telling it to. 3 labs, 3 incidents, 1 evaluator, and 1 shared root cause. The next generation of AI security might not be about building a better wall around the model. It might be about making sure a single misconfigured file can't hand a capable model the keys to a real company. This is Modern Tech Studio. If you want more of these deep, fact-checked investigations into what's actually happening inside the AI industry, subscribe. Because the story isn't just what these models can generate anymore. It's what they can actually do. For informative videos like this, like, subscribe, and hit the bell icon. See you in the next video.